Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0532 pertains to the AC pressure sensor circuit, exhibiting low voltage in the Honda CRV models from 2011 to 2016. This specific DTC indicates that the electrical signal generated by the AC pressure sensor is below the expected threshold, which is less than 0.24 volts. The AC pressure sensor plays a critical role in monitoring the refrigerant pressure in the AC system, ensuring optimal performance of the air conditioning system by providing real-time data to the powertrain control module, PCM. Located typically near or attached to the AC compressor or accumulator, this sensor's failure can lead to the AC system not functioning correctly, resulting in inadequate cooling or total system failure. It is essential to carry out thorough diagnostics to pinpoint the exact issue causing the low voltage reading before proceeding with repairs. Following the outlined troubleshooting steps can ensure an efficient repair process. The DTC P0532 indicates a low voltage reading from the AC pressure sensor circuit, which can affect the air conditioning system's functionality. The AC pressure sensor is responsible for detecting the refrigerant pressure in the AC system, sending this vital information to the PCM to adjust the compressor operation appropriately. The exact location of this sensor is often near the AC compressor on the engine bay or linked to the AC accumulator. A low voltage condition, specifically less than 0.24 V, suggests that the sensor may be faulty, or there could be an issue with the associated wiring or connectors. Issues such as corrosion, loose connections, or broken wires can result in these readings. Ensuring that there are no interruptions in the signal is crucial for maintaining the overall efficiency of the air conditioning system. Several potential causes can lead to the P0532 code being triggered. The most common is a faulty AC pressure sensor itself, which may not be sending accurate readings to the PCM. Additionally, poor wiring or loose connections between the sensor and the PCM can cause inadequate voltage levels, leading to the low voltage condition. Corrosion and dirty terminals can also impede the electricity flow, simulating a sensor issue when it is actually just electrical interference. Moreover, there may be a short circuit in the wiring harness, particularly in the PD sensor line, which can cause incorrect voltage readings. Each of these possible causes must be investigated thoroughly to identify the root of the problem and correct it appropriately. The symptoms associated with DTC P0532 generally revolve around the performance of the vehicle's air conditioning system. When the AC pressure sensor transmits a low voltage reading, one of the prominent symptoms observed is ineffective cooling, meaning passengers may notice that the air conditioning is not blowing cold air as expected. Additionally, inconsistent AC performance can occur. The system may work intermittently, causing discomfort to vehicle occupants. Furthermore, the presence of DTC P0532 itself on the diagnostic tool is a clear indication that troubleshooting is necessary. It's crucial to address these symptoms promptly, as prolonged exposure to a malfunctioning AC system can lead to further damage and costly repairs. The first step in troubleshooting the P0532 code involves verifying the problem by starting the engine and allowing it to idle. Once the engine is running, you need to activate the blower switch to ensure that the climate control system is operational. Following this, turning on the AC switch is crucial, as it allows the AC system to engage and the AC pressure sensor to send voltage readings. At this point, utilize the Honda Diagnostic System, HDS, to check the current voltage readings against specified thresholds. Specifically, you'll want to verify if the AC pressure sensor is registering a voltage below the expected 0.24 volt threshold. If it confirms that this failure is duplicated, you will proceed to the next troubleshooting step. If it does not match, it may indicate an intermittent failure, urging you to investigate connections and terminals associated with the AC pressure sensor and PCM. For the second troubleshooting step, begin by turning the ignition switch to the off position, or lock, 0. This is vital for safety, as you will be working with electrical components. Next, disconnect the AC pressure sensor utilizing the 3P connector. This step isolates the sensor, allowing you to focus on diagnosing the sensor circuit. Once the connector is removed, turn the ignition switch back to the on position, II, which powers the vehicle's electrical systems without starting the engine. Utilize the Honda Diagnostic System, HDS, again to check the voltage output from the AC pressure sensor circuit. The objective is to see if the voltage is still below 0.24 volts. If it is, the next logical step is to go deeper into diagnosing the sensor itself or other components. If the voltage reading does not match, it suggests the system is functioning adequately at that moment, pointing to a possible intermittent issue. The third step in the troubleshooting sequence requires measuring the voltage at specific test points while maintaining the ignition in the on condition. First, ensure that the AC pressure sensor's 3P connector remains disconnected for this test. You will measure the voltage between two test points. Test point 1, which is the AC pressure sensor connector, number 1, gray color wire, and test point 2, which is connector number 3, red color wire. The expectation is to find approximately 5.0 volts in this scenario. If this voltage reading aligns as expected, it confirms the integrity of the wiring leading to the sensor, indicating that you will need to replace the AC pressure sensor itself. If not, you will progress to the next step to further isolate the issue. In the fourth troubleshooting step, you will begin by turning the ignition switch to the lock 0 position, ensuring safety and preventing any electrical issues during the test. Next, make sure to jump the SCS line using the HDS. This is a diagnostic feature that allows for testing circuits while the system is offline. Disconnect the PCM connector, A49P, as part of this step. After you have performed these actions, you'll check for continuity between specified test points once again. Test point 1, PCM connector A number 30, red, and test point 2, AC pressure sensor 3P connector number 3, red. Continuity will confirm a solid connection through the VCC6 line. If you do find continuity, this indicates that the VCC6 wire is functioning correctly. If there is no continuity detected, further investigation is warranted throughout the wire leading back to the AC pressure sensor, ensuring proper electrical flow. The final troubleshooting step is crucial for verifying the integrity of the PD sensor line. Before initiating this test, ensure that the ignition switch is turned to the lock 0 position for safety. Just as in previous steps, you will jump the SCS line using the HDS diagnostic tool. After this, disconnect the PCM connector A49P to isolate circuits effectively. Check for continuity between the AC pressure sensor 3P connector number 2, blue color wire, and the body ground. Finding continuity in this check indicates a short circuit within the PD sensor wire between the PCM A27 and the AC pressure sensor. If continuity is found, immediate repairs must be initiated to correct this short circuit. If continuity is not present, confirming that the PD sensor wire is intact allows for further action, such as updating the PCM software or replacing with a known good PCM. After completing the necessary repairs or component replacements, conducting repair verification is essential to ensure that all issues are resolved. Begin by turning the ignition switch to the lock 0 position, and then reconnecting all the previously disconnected connectors. Next, switch the ignition on 2, which brings the vehicle's systems back to operational status. Use your HDS tool to reset the PCM, which is vital for clearing any stored fault codes or anomalies in the control module's memory. After resetting, perform a PCM idle learn procedure for accurate performance monitoring. Finally, start the engine and allow it to idle while checking for any pending or confirmed DTCs. If the P0532 code is still present, cross-reference any wiring issues or installation mistakes, and if resolved, document the completion of the troubleshooting process. Preventive maintenance plays a significant role in minimizing the likelihood of encountering the P0532 DTC in the future. Regular checks of the AC system can catch issues with the pressure sensor or associated components before they escalate into significant failures. It is also essential to inspect electrical connections for signs of corrosion, wear, or looseness, as these can lead to inaccurate voltage readings. Make seasonal inspections of the AC system a habit, particularly before summer months when the demand for cooling is at its peak. Furthermore, ensuring that the PCM software is updated can prevent compatibility issues between the vehicle systems. Keeping these maintenance practices in mind contributes to prolonged vehicle life and reliable air conditioning performance. In conclusion, DTC P0532 is a critical diagnostic code indicating low voltage from the AC pressure sensor and highlights the crucial role the sensor has in the proper operation of the vehicle's air conditioning system. Following the structured troubleshooting steps outlined can efficiently lead to the identification and rectification of the underlying issue causing this fault code. It is also vital to conduct repairs methodically, verifying each step and ensuring all connections are secure post-repair. As a preventive measure, integrating regular maintenance checks for the air conditioning system into your service routine can significantly reduce the chances of recurring faults. Keeping the PCM software updated and regularly inspecting the wiring and connections will further enhance reliability, ensuring a cool and comfortable ride for the vehicle occupants. Please like and subscribe to the channel. See you next time.